When shaken vertically, fluids exhibit surprisingly rich behavior. This is the well-known Faraday experiment. Here we see how a glycerin surface develops into a jet. Recordings with a high-speed camera reveal the process of jet formation. The falling mass of a surface wave creates a void in the fluid, which collapses from bottom to top and focuses into a strong upward jet. Sometimes the void collapses in the middle and an air bubble is entrained. Now the upward jet is weaker and a downward jet pinches all the way through the bubble. At higher frequencies of shaking, we observe a chaotic ballet of surface waves and jets, which are again formed by the collapse of voids created at the fluid surface. To learn what happens in a granular medium, we now pour fine sand into the setup up to a height of 6 mm and repeat the experiment. Surprisingly, also now we see thin jets shaped as sandy worms. They reach heights exceeding the original thickness of the layer by 10 to 20 times. The jets emerge from an airy cloud of grains, almost like protuberances from the corona of the sun. How do these jets form? To reveal the mechanism, sand is shaken in a thin rectangular box. The sand accumulates in ripples, and below each of these ripples, air is entrained by the convective motion of the grains. Air bubbles form at the bottom and slowly rise through the sand. Every time a bubble reaches the surface, it creates a void, which thereupon collapses into a jet. In conclusion, the formation of surface voids in a liquid and in sand evolves along strikingly different paths. Their collapse, however, in both cases creates a firework of jets.